Hello and welcome to this video in which we're going to take a look at what a function is. A function is basically a mathematical statement relating to quantities. So an example of a function would be something like y is equal to x plus 4. Basically, we are defining the x term or the y term in terms of an x value. The x would be called my input, also known as my independent variable. Okay. By picking a value for x, and a lot of times we use these what are called function tables, where I give values for the two variables. If, for example, I pick an input of x equals 1, when I plug the x value in, I would get y by doing 1 plus 4, which then would give me my output of 5. So the y value would be known as my output. It would also be known as my dependent variable, because what y is depends on what my value for x is. And these are functions because there is no just one combination. So for example, I could pick x is equal to 10. I would plug it in, the value of x in, I would get 10 plus 4 to give me my output of 14. So these are what are called basically function tables. This would be an example of a function, the y equals x plus 4. Now, to tie in with sort of beginning to get some graphing down. Let's suppose I give you a function along the lines of y equals 3x minus 4. Okay. What I would do is set up a function table. Okay. And what I might recommend is using one that looks like this, where I have the x and the y separated, I leave a space for the work, and then I leave a space to give what my coordinates are. So if I pick an x value of, say, let's just say x is equal to 3. I would do 3 times 3 minus the 4, okay? Because this is the 3x minus 4 that I'm plugging the x value into. So 3 times 3 is 9. 9 minus 4 is going to give me a y value of 5. Okay. Let's suppose I picked x is equal to 2. Then I would do 3 times 2 to plug the x value in for x minus 4. 3 times 2 is 6. Minus 4 is going to give me 2. So let's do a value of x equals 1. I have 3 times 1 minus 4. 3 times 1 is 3. 3 minus 4 is going to be negative 1. Okay. So what I begin having here is these coordinate pairs. 3, 5, 2, 2, and 1, negative 1. And I'm getting these values straight from the x values here and the y values here. These are my inputs, these are my outputs. So then I go to graph. So given this graph, I need to plot each point. So I take the 3, 5. The 3, I do my x value first, so I go over 1, 2, 3, and then I would go up to 5. So my very first point would be at 3, 5, which would be right here on the graph. Okay. My next value would be 2, 2. So I go over 2 and up 2. This would be my next point on the graph. 1, negative 1, I go over 1 and down 1 would give me a point here. So basically, if I look at this graph, if I connect these, I'm basically looking at a graph represented here. This would be the graph of the function y equals 3x minus 4. It happens to be a straight line, okay, which will begin to tell a story. But this idea of a function, okay, just as a little bit of a side note here, I can tell any function I have if I were to draw a vertical line, okay, and then take that line and move it, at any given point, it should just cross the line once. So if I were to take a graph, like let's say my graph looked like a circle, if I was to take this line, it would cross twice. It would cross, say, here and here while it's staying still. This would be not a function. Okay. I could have something that looked a little like this. Okay. That's fine, because if I move, it only touches it once at any point on the graph that I can move this line. It'll only touch the line one time, so it would be a function. Okay. That part really isn't in the book at all, but it will come in handy kind of as the year goes along and as you move into algebra, just to begin thinking of a function being basically like a straight line, okay, or graph. It could be a curved line as well, but it can't sort of double back on itself like a circle does, okay? So it has to pass this vertical line test. So these are your inputs and your outputs, then that will form the graph, okay?